Okay, so good morning or good evening, depending on the time you'll be watching this. So welcome to soil compaction. So we have looked at soil classification. So for any soil to be compacted, we first need to know the type of soil we are going to compact by classifying it. So today we are going to look at compaction. So what is compaction? So compaction is the densification or increase in density of a soil mass by reducing the air voids. It's very important. Here we reduce the air voids. Is that okay? Okay, so through expulsion of, yeah. Remember we said that. Remember we looked at the formula for increase for the air voids. Remember if we can all recall, we said that this one is equal to E to E to E V V into 1 minus S. So if you can remember, so we are E the void ratio. So remember we discussed and we said that the best way you can improve a soil by somehow increasing the degree of saturation. We shall say, but the water, the reason why we shall be putting there water. So here we get a zero air void. That's why in compaction somehow we put in water. But our water it's not to saturate the soil, but lubricate these particles so that they can be easily compacted to reduce the friction and the particle between the friction between particles, so that you can increase the density. There is no substantial change in volume of water in a soil mass during compaction. So our purpose, why? Because our purpose is not to compress the soil, but to compact the soil. It's only during the compression of soil or consolidation that's when we expel out water. So our purpose here is normally to just increase the density by expulsion of air, as you can see, by slightly increasing the degree of saturation to be equal to 1, so that we can have zero air voids. So we can see that compaction is done to improve the engineering properties of soil, such as increase in shear. Indeed, you increase the shear strength because the shear strength depends on the internal friction or how the interlocking properties of soil, how well the soil is interlocking. So by increasing the particles, so the particles within a mass, therefore increasing the internal friction of the mass, therefore improving the shear strength. So increasing the bearing capacity. However, if you increase the shear strength, you automatically increase the bearing capacity, because the bearing capacity is a function of shear strength. And which shear is a function of both the angle of friction and cohesion, as we shall see. Then change in the soil properties such as shrinkage. There will be reduction in shrinkage. Is that okay? Because shrinkage normally occurs when there is space and the soil can reduce in what? In size. But when you compact the soil, you have increased the masses, therefore you reduce the tendency of a soil to reduce in what? In its length or to shrink. To reduce on frost. Frost occurs because there are voids and there is water. So, but if you have filled all the voids, if I fill all the voids with particles and there is no voids to store water, therefore there will be less of frost action taking place. Automatically, also there will be reduction in what? In the permeability of the soil. But this is normally achieved by using mechanical compactors, e.g. rollers, rammers, with the addition of water. So what we add water, some started to increase the degree of saturation, but also to lubricate these particles you are compacting, to reduce the internal friction, so that you can easily compact the soil into a dense mass. So the objectives of compaction are: 1, to increase the shear strength of soil. How do we increase the shear strength? What is the importance of increasing the shear strength of soil? Yeah, increase the bearing capacity of our foundation support. That's why in compaction, if you have a weak foundation, the best way to improve its resistance to shearing is by compacting it. There you increase, obviously you increase on the density of these particles, therefore increasing the strength. So ample resistance against slope, side slopes instability of the embankment. That's what you because when you are comparing, you are forcing these particles to into a closed interlock. Is that okay? Therefore you can increase it. But why? Because also the slope stability is a function of the angle of friction, and the angle of friction increases with increase in what? How the power particles are highly compacted. So reduce on compressibility of soil. Compressibility of the soil, this is normally the ability of a soil to move vertically. So therefore, if you have put a particles together and there are no voids for a soil to move in, therefore you have produced it's less compressible. So smaller deformation of soil, hence track this railway track or road. There is less deformation. Is that okay? Because there is less. You have reduced on the deformation, on what called on the plastic deformations and also elastic deformation by compacting soil into a dense matter. Because deformation is about movement of soil, a vertical movement of soil. Reduce the dry shrinkage and formation of cracks on drying. How does it reduce on the degree of shrinkage? The degree of shrinkage is reduced in such a way by increasing the particles within a unit mass of soil. Hence, the reducing ability for it to shrink, because you are reducing the possibility of shrinkage occurs when the water goes into a material, and that material, when it exposed to dry condition, the water escapes. Hence, the material, and it is also is more common in clay soils. So when you compact a clay soil to a denser mass, you have to reduce the ability for it to go through shrinkage or reduction in length of a material mass. It also leads to less seepage. Because why? Because the voids, the space where they have been filled with soil particles, therefore there will be no interconnected voids to carry water through a soil mass. So how do the means of achieving compaction? So we can use rollers. This is a common, I think everyone, you have seen this on sites if you have trained. You can use rollers. Also we have the sheep foot rollers and also small foot rollers. These are normally used for fine grained soils, because for fine grained soils we compact them in smaller lifts. Okay, lifts which should not go beyond, I think, 200 millimeters. Why do we combine? Because for them we are placing, to reduce on the compressibility of a soil and expel out also to expel out the air. Then the sheep foot also can be used on the same type of soil, so fine grained soil, and also others. Then another one, you can use a vibro flotation. These are normally for coarse grained soils. And normally these are used to reduce on the tendency for occurrence of what called liquefaction. Liquefaction is a bit where a material flows like a liquid due to the presence of water and loading. When the material, or because of that, there's an earthquake, for the poor water pressure moves the water within, moves with the soil particles. But when you compact this soil, and these particles rearrange themselves. So normally for sand soils, to improve their strength and to increase, normally we vibrate them. So you can use what called the vibro flotation method. You're using a vibrator. You dig deep, then you vibrate. When you vibrate, the soils, they rearrange themselves since they are free to move. They are coarse grained. While for fine grained soil, we normally use rollers such as the sheep foot or the smooth rollers. For coarse grained soils, for example, sands, or you are compacting, or you are reclaiming land in a swamp and putting there sands, you can easily compact and get a dense mass by using a vibratory flotation method. So factors affecting compaction. So which factors do affect compaction? One, we say the soil type. We have talked about the choice of equipment to compact, the choice between rollers and vibration. This roller is application of weight. When we load, we are applying weight, where we are applying a vibration load. Is that okay? So how do you choose? Now, between this equipment depends on type of soil. For fine grained soils, we say that we normally use rollers. For coarse grained soils, what called grain soil with grains, particles, normally we use what? Sands. You know what sands are? We will discuss that in classification. Normally use a vibrator. Then the moisture content. Okay, so we shall say that the more the moisture the moisture content is very important, because what we said, water helps in lubricating the soil particles so that they can further be compressed into a denser mass. And also the effort, the energy you apply, the weight. The bigger the effort, the more the density you are going to achieve. Okay. Then also the thickness of the layer or the lift. Remember I said the lift depends on the type of soil also. So the thicker, if you want to achieve higher compaction, you achieve what? Use smaller lift. If that is for fine grained soil. For coarse grained soil, since you are vibrating, you can compact them in bigger shifts. So you can look at the normal soil. Before compaction, you have water, air, and solid. Is that okay? So soil block after compaction. So somehow you have reduced on what? You have put adding more particles, adding more soil blocks. You reducing on air, but the water you can see that the water fraction is remaining. Therefore, you are increasing the dry density by adding more soil particles. These are soil particles. Is that okay? Adding more soil by expulsion of air, by application of a load. So what is the best concept of compaction? So when a material is saturated in this form here, we assume this is a saturated material. Okay, not so saturated, but let's assume that this is the material. If you can remove this, let's remove this. Now this is a material which is a natural bulk unit weight. So it's given by Gs plus Es. Width is in this form. We have water, air, water. Sorry, we have air, water, and solids. As we could get to a bulk unit weight. So when a material, if you want to compact a material, material should be dry to achieve a dry material. Therefore, we assume that the degree of saturation will be equal to 0. Now this one cancels out. When this is equal, now we achieve such a material. That the dry unit weight is equal to Gs over 1 plus E times the unit weight of water. But also we can see which is equal to bulk unit weight divided by 1 plus W. We derive this in our first chapter. Which is equal now if you come to substitute for W, you know that W is equal to E S over Gs. So you make E the subject, where E, that is this is void content. This is the void. This is what we call the void ratio. Sorry, the void ratio is equal to W Gs over S. Then you substitute it here for this. We substitute, we get this, as you can see. Is that okay? Times. Now, for what is a theoretical? Now, at what point we have the minimum voids, and those minimum voids should be basically filled with water. When we say that when the degree of saturation is equal to 1, is that okay? When all the air has been driven out, and you have the minimum voids is achieved when the degree of saturation is equal to 1. When remember, if I can take you back to simple this, we say that which is equal to 1. When this is 1, we don't have this one. This is we see that the air void portion is equal to 0. So at that point, so according to our formula, we can go back simply here. When this is equal to 1, we have the minimum void. Is that okay? Now, this is a theoretical one, and when S is equal to 1, is that okay? When S is equal to 1, so we can plot the different theoretical values basing on the degree of compaction or the compaction energy. So you can see that when it's equal to 1 will be the highest, it will be the air, or we call the zero air void line. This one here, the zero air void line. But when we reduce the degree of saturation to 80% or 60%, you can see that our lines, the air void lines, you can have them in such what you can plot them. You can achieve this using this equation here. When you vary this, is that okay? With the different water contents, you can be able to achieve such plots. These are linear plots. So moisture content and compaction. What is the importance of moisture content? The degree of compaction of soil is measured by the unit weight and optimum moisture content. Okay. Remember I said the way because you want to get at water, and that water, when the material can give the maximum strength, when you have lubricated all the soil particles such that the material is highly compacted into a dense mass. Then by reducing the air voids, moisture can be added to the block. I said by reducing the air voids. When moisture is added to the block, the water content WC is increasing. The soil particles will slip on each other